By definition, an angle is formed by two rays with the same endpoint. An angle is formed by two rays that share an endpoint. The endpoint that they share, we call that the vertex of the angle. And like segments, lines, and rays have symbols, angles have symbols, and that's what's here behind the word angle. This is your symbol for angles. Angles can be named differently. The most common way you name an angle is by using three letters from the angle. So we could name this angle angle T, B, Q, and I'm sure you have that one already on your paper, don't you? Yes, okay. I could go the other way and name this angle Q, B, T. Your vertex, the endpoint that they share, must be in the middle when you're using three letters. Okay, the vertex of the angle has to be the middle letter when you use three letters. That's the one you'll use like 85% of the time, the way of naming it. I can also name this angle angle B. I can use just the vertex and call it angle B. And the third way, if there's a number inside of the angle and it's less than 9 and doesn't have a degree symbol, then that is naming the angle, and I could also name this angle 1. Okay, most of the time you'll use three letters. Generally then, sometimes you'll use just the vertex, and then lastly you'll use whatever number is in there. Because sometimes I don't know which one to use, and the curve is in there so that it doesn't look like a less than sign. So I'll go back and forth using an open angle sign, or I'll put the line through it, and that's just there so it doesn't look like a less than sign. But they mean the same thing. Okay? All right. You don't have this one on your paper, but we'll just look up at it. It says, can you name angle ABC? So following the letters, A, B, C, that would be all of this, as angle B? Would I name this angle angle B? I could. It's its vertex, right? That's what we did right up here. Could I name angle ABC angle 1? No. Could I name it angle 2? Can I name all of this angle 2? No, because 1 is the left portion and 2 is the right portion. That wouldn't make sense, would it? Riley? No, don't do that. It's a good thought, but no. It is a good thought. I like where you're going, but no, don't do that. I like it's even more confusing. Okay. All right. Cool. So definitions, we're going to where you have all those blank lines. An acute angle. So based on angle measures, you can classify angles differently. What would you say the measure of an acute angle is? Rashid? Under 90 degrees. Good. An acute angle is an angle less than 90 degrees. You can write it word for word and write between 0 and 90, or just write less than 90 degrees. You don't have to write out every single word that I have typed up here. Write what makes sense to you. An acute angle is less than 90 degrees. Bless you. How about a right angle? What's the measure of a right angle? Sarah? Okay. Brain? Yep, a right angle is equal to 90 degrees. And you could just write equals 90 degrees right on your paper. You don't have to write all that out. A right angle will always equal 90 degrees. When you have a right angle, not very often they'll put the number 90 in there. They will just put this little symbol here to form a nice square, because squares have 90 degrees. Okay? So this is your right angle symbol when they put the little, I don't know, half square there to make a whole square. Bless you. Okay. How about an obtuse angle? Yeah. It's between 90 and 180. Can it equal 90? No, but it could be like 90.5 degrees, couldn't it? Okay. An obtuse angle goes between 90 and 180. They're big. They're obtuse. Acute. They're small. They're acute. How about a straight angle? What would you say a straight angle is?
180.
Yeah, exactly 180. So on your straight angle, you could write equals 180 degrees. A straight angle makes a straight line. Congruent angles. What do you think congruent angles are? Angles of the same degrees measure. Good. Congruent angles are angles with the same measurement. Congruent segments have the same length, so congruent angles have the same measure, have the same degree measure. And that congruent symbol is up there again for you. I have two angles that are 140 degrees, so I would say those are congruent angles, they're the same measurement. Above your definitions, there's 4 different angles. We're going to classify them. So this first one, it's either going to be acute, right, straight, or obtuse. Bless you. Mason, what would you classify this first angle as? Acute. Good. Ben, an acute angle is between 0 and what degrees? 90. Good. Can it equal 90 and be an acute angle? Ben? If it equals 90, is it an okay, good. Sydney, how about this next angle? It's a right angle. Emma, so what does it equal? 90 degrees. Good. And here's your right angle symbol in there. Paige, how would you classify the third angle? An obtuse angle. Good. Jack, an obtuse angle is between what and what? 90. Good, 90 and 180. Dawson, how about this last one? Good, a straight angle. Dylan, what does a straight angle equal? Good, 180 degrees. This whole angle is 180 degrees. All right. Number 1. I have the wrong fixture up here. Put a number 3 in your angle, but name that angle in 4 different ways. Name that angle in 4 different ways. Jacob, what's one name for it? Angle COB. Good. Brady. Angle BOC. Sarah. Angle 3. Tyler. Angle O. Good. There's 4 different names for that angle. All right, go ahead and do number 2. Classify each of those angles as acute, right, obtuse, or straight. Yep. No, you can do it just like you did. JC, this first angle, COB, how would you classify that? Obtuse, good. Cade, how about angle AOB? Straight. Riley, how about the second COB? This one? Acute, good. Some of it. All right. Questions on classifying and naming the angles? Okay. We have another postulate to add today. The other day we did the segment addition postulate. Today we're doing the angle addition postulate, which states if point B is in the interior of angle AOC, interior, what does that word mean? Inside, excellent. Okay, so angle AOB would be all of this angle. B is in the interior of it. See that how it lays inside of it? Okay, if that happens, then it's true to say that the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Makes sense, right? The left side plus the right side would give me that huge angle AOC. Yeah? Yeah, all right. So it's something you probably did before, but we didn't know it was the angle addition postulate. The second portion of it says if angle AOC is a straight angle, then the measure of angle AOB, this guy here, plus the measure of angle BOC, this guy here, would equal what? Good, AOC. You could write that down. But because it's a straight angle, I know for sure they have to add up to what? 180. That's what I'm looking for, really. Because it's a straight angle, we know that these two have to add up to 180, which is the measurement of angle AOC. That's just part of your angle addition postulate, that if you have two angles that make a line, they have to add up to 180. Yes, I'd rather you write 180. Both the segment addition postulate and the angle addition postulate, you only ever add two things to make a third. You really wouldn't say adding three angles to make a third or fourth angle, I guess. Okay, angle addition and segment addition, you just add two parts to make one whole. All right, okay. I'm sorry about this next image. You should not have your right angle symbol in there, so maybe you want to cross it off. That doesn't need to be in there. Instead, we're going to go based off of what they tell me the directions. So suppose that the measure of angle 1 is 42 degrees. I'm going to put a little 42 in there. And the measure of angle ABC is 88 degrees. I'm going to put the big curve, because then I know I'm talking about all of that. Okay, if you just put an 88 inside angle 2, how are you going to know if it's angle 2 or the whole thing? Make sure you're labeling clearly there. We need to find the measure of angle 2, and it says to use the angle addition postulate to do so. Sarah. Add them together. Okay, angle 1 is here. Here's angle 2. What's the measurement of it? Is it? Is that what it says? No, we don't know it. 88 is this whole thing, the two of them together. So what would you have to do to get the measure of angle 2? Subtract them. Good. Where it says use the angle addition postulate, I could write it out this way. I could say that the measure of angle, well, 1, plus the measure of angle 2 would have to equal the measure of angle ABC. You guys agree? Yeah, and then I could use substitution. Angle 1 is 42. I don't know what angle 2 is, so I'm going to leave that as is. And the measurement of angle ABC is 88. To get angle 2 by itself, we'd have to do what with 42? Subtract it. Good. 88 minus 42? 46. All right. When you go to tell me the measure of an angle equals some degrees, you need to put this little m here. The measure of an angle equals. It's notation. You would not write angle 2 equals 46 degrees. That's not correct notation. Just like with segments, when I talk about the length, we don't put bars over them. For angles, when we talk about third degree measure, you got to put that little m in front of it, the measure of. Right? All notation. Questions on the front side? No, just show me 88 minus 42. Okay, I want you to flip it 2 pages. We're going to go all the way to example number 6. Where it says, using the diagram at the right, name angle CED 2 other ways, and then there's part B. Go ahead and try this one on your own. Kylie, what's one other name for angle CED? Angle 2. Yep. Emily? Good. Angle DEC. There are your 2 other names for angle CED. And then it says, would it be correct? I don't know if I want to use the word correct, but would it be okay to name any of those angles angle E? Why not, Nick? Supply. Because there's two angles at E, right? Yeah, if I said angle E, which angle are you thinking about? Oh, I was thinking about just angle 1. See why it's confusing? If I name that angle E, which angle am I talking about? Nick said he was thinking about the two of them together, where I was only thinking about angle 1. Okay? So I don't really want to say the word correct. I guess I want to say like okay, less confusing. Would it be okay to name any of these angles angle E? Not really. Explain more than one angle at vertex E. Confusing. Like in my first period, I have two Isaac B's. If I say Isaac B, how are they going to know which one I'm talking about? I have to be more specific. I actually have to say their full last names. Riley Larson.
Couldn't you just call it E1 and E2?
What about the big one?
That's called E3.
No. Tyler. Seriously, you're going to ask the same thing? For 5 years, I've never had anyone ask that question, and the two of you are going to ask it at the same time. You guys are. No, you cannot. You have to use 3 letters then, or the number that's there. Okay. All right. I think most of you already did 7 as I was walking around. If you haven't, I'll give you a few seconds here to go ahead and classify the 4 angles on number 7. Maddie, how would you classify angle, or the first angle there? Obtuse, good. Morgan, how about the second one? Brady, how about the third one? A right angle, good. How did you know that? Good, excellent. There's your right angle symbol. Shy, how about the fourth one? Good, this is a straight angle. All right, to number 8. The measure of angle DEG equals 145. Okay, follow the letters. DEG, that's this left side. We have to find the measure of angle GEF. Go ahead and take a second here and find the measure of angle GEF. There are people that do. They like do GEOFF, GEOF. I've seen it. I've seen it. Yeah, I know. That's what I just said. Yes, it would. It'd be perfect. Rose, what should we do here to find the measure of angle GEF? Subtract from angle DEF. Rose, do you know the measurement of angle DEF? How'd you know it was 180? Good, it's a straight angle. Awesome. So 180 minus 145, 35. The measure of angle GEF equals 35 degrees. Make sure you have the measure of the angle. Okay? If you don't put the measure of an angle, and especially if you don't even put the angle symbol, then it looks like you're naming a plane. Because don't we name planes with 3 capital letters? Yeah, okay, so you have to make sure you put the symbols there so everyone knows what you're talking about. Questions? Okay. Let's try something here. Any idea what those curve marks mean? They're congruent. Excellent. The curve marks mean they're congruent. We use hash marks on segments. We use little curves and angles. So we could say that angle AEB is congruent to angle CED. The little curves, they're going to mean they're congruent. In your book, they're going to be like that pinkish red color, just like the segment hash marks were. Okay? That's just a random one that I threw up there. Okay. Solve this for x. I don't know, at the top of the side you're on, in the margin. Solve this for x. AED, right? How many angles in my picture make up angle AED? 3 of them, right? But I only know information about 2 of them. Good. AEB is congruent to CED. It's marked and I have it stated here. So if AEB is 5x plus 2, what's CED got to be? 5x plus 2. Now I have something about each of them. So if I take this first angle, AEB plus BEC plus CED, all 3 of those have to add up to what? 117. Good. All right, so we would have 5x plus 2 plus 8x minus 1 plus 5x plus 2 equals 117. 5 and 5 is 10 plus 8 more, 18x. 2 plus 2 is 4 minus 1, 3. How do I bring my 3 over? What's 117 minus 3? How do I get rid of the 18? And when you guys threw this in your calculator, what did it shoot out? All right, so it's either 6 1/3. You could write that as 19/3 if you like improper fractions. Or you can write that as 6.3 repeating. But it's not 6.3. Okay, it's one of those 3. I probably would not do this because when you go to check your answer in the calculator, have you guys ever found a repeating bar button? What? They should have one, right? Or we would just use our fraction form. Okay? All right, questions on the notes? All right, good deal. We will finish them on Tuesday. Here's your homework for the weekend.